want to solve the following equations by the square root method. So that means we want to write the equation as a perfect square equaling a number. So this term is our perfect square term, so we'll add 18 to both sides. And I have x squared equals 18. So then we'll apply the square root property, taking the square root of both sides. We would get x equals plus or minus the square root of 18. So the square root property allows us to basically take the square root of both sides, plus or minus, and then simplifying 18, so square root of 18 into the square root of 9 times the square root of 2, we would end up with x then equaling plus or minus 3, it was the square root of 9 times the square root of 2. For b, we notice our term on the left is a perfect square, so we do want to apply the square root property right now. So the square root of the left side, square root of the right, we'd be left with x minus 2 equaling plus or minus the square root of 25, which is 5. So again, this plus or minus 5 represents two numbers. To solve for x, we'll just add 2 to both sides. So x equals, and I need to leave this as two terms so I can evaluate both. So the 2 plus or minus 5, we'd have x could be equal to 2 minus 5, or x could be equal to 2 plus 5. So x equals negative 3 or 7. X equals 7. Again, the plus or minus is just nice shorthand notation that we can use when we're evaluating. All right, so for C, again, we have a perfect square term on the left, so we take the square root of both sides. The square root property would give us x minus 4, and that would equal plus or minus the square root of 21. So to solve for x, we would add 4 to both sides. We would get x equals 4 plus or minus the square root of 21. So these would be the exact answers, exact solutions. And we can approximate each one of those, x equaling 4 minus the square root of 21, we can approximate with our calculator. So when we plug this into our calculators, 4 minus the square root of 21 would give us a negative 0.5825 or 583. And then for x equaling 4 plus the square root of 21, if we put this in our calculator, we'd get approximately equal to 8.583. So I just rounding to the third decimal place. All right, so for the last problem, again, we see a perfect square on the left side and a number on the right, so we'll take the square root of each side. The square root property would give us a 7a minus 2, and that would equal plus or minus the square root of 8. So again, we want to solve for a, and we can simplify the square root of 8. So we'll simplify that. We'll add 2 to both sides. We'll get 2, and then plus or minus the square root of 8 would be a 2 square root of 2, and then 7a is equal to that. So the square root of 8 is the square root of 4 times the square root of 2, so we could simplify that to 2 square root of 2. So then dividing by 7 on both sides, we get a equals 2 plus or minus 2 square root of 2, and that's all over 7. So each one of these would give us a value. We could approximate each one of these. And if we plug those into our calculator, we would have 2 minus 2 square root of 2 over 7, which would be approximately equal to, so 2 minus 2 square root of 2 all over 7 would be approximately equal to 0.8 or 0.0836 or 84. And then 2 plus 2 square root of 2 all divided by 7 would be approximately equal to 0.4877 or 488.